course of Electric Machine 2, lecture number 5, week number 10. Today we are going to start a very important topic, that is alternators. We are familiar with alternator. It has some names like generators, AC generators, alternators. So let's start. Alternator introduction. As we all know, nowadays a three-phase AC system being exclusively used for generation, transmission and distribution of power. The machine which produce three-phase power from mechanical power is called an alternator or synchronous generators. Alternator are the primary source of all electrical energy we consume. These machines are the largest energy converter found in the world. They convert mechanical energy into AC energy. In this chapter, we shall discuss construction and principle of operation, parallel operation, and regulation of alternator by synchronous impedance method. So alternator is an important machine. It produces a three-phase AC and we use it for the conversion of mechanical energy into electrical energy. Alternator are also called synchronous generators. It is used in the power system. We generate three-phase power from it, then transmit it and distribute it in industries, in houses, in shops, in hospitals. So what is alternator and how it works? An alternator operate on the same fundamental principle of electromagnetic induction as a DC generator. In our previous course, we studied the detail of the DC generator. So alternator or AC generator also operate on the same principle of electromagnetic induction. When the flux linking a conductor changes, an EMF is induced in the conductor. Like a DC generator, an alternator also has an armature winding and a field winding. Alternator have two basic parts, two important parts. One is armature winding and the other is field winding. And we all know when the flux linking a conductor changes, an EMF is induced in the conductor. What is the difference between AC and DC generator? There is one important difference between the two. In DC generator, the armature winding is placed on the rotor and field poles are placed on the stationary part of the machine. Field are stationary and armature is on the rotor, so it's rotate. In alternator, we have the opposite of the DC generator, that is it has field winding on the rotating part and armature winding on the stationary part. Why? Because no commutator is required in alternator. Commutator is used for the conversion of AC into DC. It is usually more convenient and advantageous to place the field winding on the rotating part and armature winding on the stationary part. This is the figure in which there is a simple generator having three-phase supply. This is a stationary part, stator, and a rotating part, that is field winding, rotor. Advantages of stationary armature. The output current can be led directly from fixed terminal on the stator or armature winding to the load circuit without having to pass it through brush contact. Due to simple and robust construction of the rotor, high speed of rotating DC field is possible. This increases the output obtainable from machine of given dimensions. Slip ring are transferred to the low voltage, low power DC field circuit, which can therefore be easily insulated. It is easier to insulate stationary winding for high voltage, for which the alternators are usually designed. It is because they are not subjected to centrifugal force, and also extra space is available due to the stationary arrangement of armature. So these are the advantages of stationary armature. First, we have the output current can be taken directly from the fixed terminal on the stator, and we don't need to pass it through brush contact. Due to simple construction, high speed rotating DC field is possible as we give excitation to the DC field. So this increases the output from machines of given dimension. Another advantage is slip ring are transferred to the low voltage side, mean on the rotating side where we need to excite the rotating field. And the fourth one is it is easier to insulate stationary winding as compared to rotating winding for high voltage, and because it is not subjected to centrifugal force, and also extra space is available due to the stationary arrangement of armature. Now, construction of alternator. In alternator, the two basic parts: stator, that is stationary, and the rotor, that is rotating. Stator is the stationary part of the machine and built up of sheet steel, laminated steel, in order to reduce CD current and hysteresis losses, having slots on its inner periphery. A three-phase winding is placed in these slots and serve as armature winding of the alternator. The armature winding is always connected in star, and neutral is connected to ground. In stator, the stationary part have a three-phase winding made up of stator is made up of steel, and it is a laminated steel, and its inner periphery we have slots in which winding are housed. Now, what is rotor? How it is made in alternators? The rotor carry a field winding which is supplied with the DC through two slip ring by a separate DC source. The DC source called exciter is generally a small DC shunt or compound generator mounted on the shaft of the alternator. Rotor also contain winding which is supplied with the DC source, which we called exciter. It is a small DC shunt or compound generator mounted on a shaft of alternators. Rotor construction is of two types. There are two basic types of rotor construction. In two different ways we can construct a rotor. The first one is salient pole type rotor. In salient pole type rotor, poles are mounted on a large circular steel frame which is fixed to the shaft of the alternator. The individual field pole winding are connected in series in such a way that when the field winding is energized by the DC exciter, adjacent poles have opposite polarities. Silent pole type rotor are used for low and medium speed alternator, that is 120 to 400 revolution per minute, such as those driven by the diesel engine or water turbine, have silent pole type rotor. We use it for low and medium speed alternator because of the following reason. It causes excessive windage losses if driven at a high speed and would tend to produce noise. It will be noisy if we driven it at a high speed and cause excessive windage losses. It cannot be made strong enough to withstand the mechanical stress to which they may be subjected at higher speed. So since the frequency of 50 Hz is required, we must use a large number of poles on the rotor of slow speed alternators. As there is a relationship between frequency, poles and number of speeds, we will study it in the coming slide. Silent pole type rotor have a large diameter as the number of poles is more and short axial length. This is the diagram of silent pole generator, that is the rotor of the silent pole, and this is the non-silent pole rotor shape. Here in silent pole we have poles, and here we have non-silent pole rotor shapes. We will study now non-silent pole, how it is. Non-silent cylindrical pole type rotor is made up of a smooth solid forged steel, radial or cylindrical, having a number of slots along the outer periphery. The field windings are embedded in these slots and are connected in series to the slip ring through which they are energized by the DC exciters. The region forming the pole are usually left unslotted. It is clear that the pole formed are non-silent, that is, they do not project out from the rotor surface. In silent pole they are project outer side, and in non-silent it is not. Higher speed alternator, that is the speed of alternator when 1500 to 3000 rpm are driven by the steam turbine and use non-silent type rotor due to the following reasons. It has a mechanical robustness and give noise less operation at high speed, and the flux distribution around the periphery is merely a sine wave, and hence a better EMF waveform is obtained than in case of silent pole type. So it's not produce noise when driven on a high speed, and another advantage is that the waveform is obtained is nearly a sine wave. These type of rotor are used for high speed. Since steam turbine run at a high speed and a frequency of 50 Hz is required, we need a small number of poles on the rotor of high speed alternator. We can use 2 poles and 4 poles for 3000 and 1500 RPM speed and 50 Hz frequency. For a machine, it has small diameter and very long axial length. So to summarize these two, silent and non-silent rotor. Silent pole rotor are used for low speed and non-silent pole are used for high speed. Here the speed is 120 to 400 RPM, and here the speed is 1500 to 3000 RPM. It has high axial length, silent pole, and it has short axial length. Now, how alternator operate? Alternator has two basic parts, as we discussed: the stator and the rotor. Stator is stationary. Rotor rotate with the help of prime mover. First of all, we excite the rotor with the help of DC source. It produces EMF and flux that is, when rotate, cut the stationary armature winding, and as it is rotating in nature, its change with respect to the stationary winding. Hence, an EMF is induced in the stationary winding, and this is given to the load. This is the simple operation of an alternator. Now let's see. The rotor winding is energized from the DC exciter, and alternate N and S poles are developed on the rotor. When the rotor is rotated in anti-clockwise direction by prime mover basically, when we are talking about the hydropower plant, it is the water they turn the turbine and hence generator rotate. When we are talking about diesel or coal power plant, it is the steam or coal that is burning produce work as a prime mover. So when the rotor is rotated in anti-clockwise direction by a prime mover, the stator or armature conductor are cut by the magnetic flux of rotor poles. Consequently, EMF is induced in the armature conductor due to electromagnetic induction. The induced EMF is alternating. Since N and S pole of the rotor alternatively pass the armature conductor, the direction of induced EMF can be found by Fleming right-hand rule, and frequency is given by the equation below. F frequency is equal to speed of the rotor, P number of poles divided by 120. So here speed of the rotor in RPM and P number of poles. So first we give DC excitation, and we have alternate N and S pole develop on the rotor, and when the rotor is rotated by a prime mover, the
stator or armature conductor are cut by the magnetic flux of rotor poles, and in this way EMF induced in the armature conductor through electromagnetic inductions, and this induced EMF is alternating since it passes N and S pole alternatively. The direction of induced EMF can be found by Fleming right hand rule. This is all for today's lecture. Thank you. We will proceed from here in the coming lecture, inshallah, and we will study further what is alternator in depth and some more details about its efficiency, EMF equations, and the voltage regulation of alternator using synchronous impedance method. Learn this and ask any question if you have. Thank you.